Good morning, good afternoon, or good evening to you. So I hope you are doing well. This is again Soil Science 102 or the Soil Fertility Conservation and Management. So I am Florinda CT1 and I will be your course facilitator for this topic. For today, we are going to start discussing Module 3 or the evaluation of soil fertility. After this module, you should be able to discuss the concept of a fertility evaluation, explain the importance of soil fertility, be familiar with the different types of fertilizers, and learn the basics of fertilizer computation. Alright, for our discussion today, we're going to start with the determination of soil fertility status and fertilizer needs of crops. Nandyan yung quantitative diagnostic techniques and qualitative diagnostic techniques for formulation of fertilizer recommendations. And then, the second part, we're going to discuss other factors to be considered in formulating fertilizer recommendations. Alright, let's start with the first part, which is the determination of soil fertility status and fertilizer needs of crops. Okay, in agriculture or in crop production, we all know that the soil is a very important aspect since it acts as an anchorage for our crops and it also provides essential nutrient elements for the proper nutrition of our crops. However, if we repeatedly plant crops to a certain soil without managing it well, there will come a time that the nutrients will be lacking from the soil, or worse, the nutrients will be depleted. So ano nga ba yung mga example ng processes that can cause nutrient loss from the soil? One is crop removal. This is due to the absorption and consumption of nutrients by our plants. So, from the perspective of the soil, kung inabsorb ng plants yung nutrients, it is also already considered a loss. The next one is leaching. Ito naman, it is mainly due to the downward movement of water. So, as water goes down the soil profile, it carries away nutrients from the topsoil going to the deeper horizons and to the water table. The next process is the volatilization or the conversion of elements into gases. Nitrogen is commonly lost due to this process, volatilization. So yung volatilization, it is available to crops or it is present in the soil as ammonium or nitrate. And kung ma-convert yan to gas, it becomes ammonia or nitrogen gas. So if that becomes gas, it will be lost to the atmosphere. The next one is soil erosion. This can be due to several factors such as the action of water, wind, or gravity. Then we have fixation. This happens when the soil is extremely acidic or extremely alkaline. So, yung nutrients natin, if the soil is extremely acidic or alkaline, it will be fixed to the soil and it will now be unavailable for plant absorption. Lastly is the immobilization. Ito naman, due to the action of microorganisms. So, the microorganisms will convert nutrients from their inorganic form to organic form. Pag naging organic form yan, hindi na siya available for plant absorption. Kasi, nutrients are only absorbed by plants in their inorganic form. Alright. To prevent nutrient depletion, we have to supply lost nutrients. Isa sa pinaka-common na solution is fertilizer application. However, the question now, How are we going to determine the lacking element para malaman natin kung ano ang isusupply natin, and how much fertilizer is needed to be supplied para naman mapalitan natin yung nawala na element. There are several techniques in determining the nutrient status of our soil. It is divided into two. We have the quantitative and qualitative diagnostic techniques. Under quantitative, we have the laboratory soil test or soil chemical analysis. Second is plant tissue analysis. And third is the fertilizer field trials or biological test. Under qualitative diagnostic technique naman, we have nutrient deficiency symptoms, the use of soil test kit or the STK, and the microbiological method. Isa-isahin nating i-discuss ang mga techniques na ito. Let's start with the laboratory soil test or soil chemical analysis. For soil chemical analysis, this is the routine partial analysis of soils for the purpose of guiding nutrient management. Ano nga ba yung process nito? First, we have the collection of soil samples from the field or the area kung saan gusto mong malaman yung nutrient content ng soil. Next, the soil samples will be brought to the laboratory for preparation and chemical analysis for the nutrient na gusto mong malaman. Let's say, for example, nitrogen, phosphorus, and potassium. After the amount is determined, it will be interpreted, and a fertilizer recommendation will be formulated. Now, yung amount of nutrient na na-analyze is only a portion of the total available amount to be released from the soil. So, the amounts of nutrients that is determined during the chemical analysis is also the amounts of nutrient that is available for the cropping season. So, basically, soil test values from the chemical analysis are merely indices of the soil's nutrient supplying power. The first step for this technique is the collection of soil samples. Now, this is a critical step since it is going to affect yung result ng chemical analysis, the interpretation of the result, and then eventually the formulation of fertilizer recommendation. That is why we need to perform soil collection properly. So, let us review kung paano nga ba yung collect ng tamang soil samples. Let's say, for example, this is your area. Okay, so we have to distribute the sampling points throughout the field for us to collect a true representative soil sample of the area. Also, we need to collect at a correct depth depending on the crop that we are going to plant. For vegetables, we should collect at a depth of 20 to 30 centimeters. We should also make sure na hindi bagong fertilized yung ating area. Well, we should not collect beside fences and under manure piles or piles of decomposing organic matter. Next, it will be brought to the lab for air drying, for pulverizing, sieving, and then this one, the storage, the proper storage of our soil sample to avoid contamination. The second step is the chemical analysis of soil. This is being conducted at the laboratory for routine analysis. So, pag sinabi nating routine analysis, ang mga dinedetermine dyan na chemical properties of the soil are the pH, organic matter content, available phosphorus content, the nitrogen content, exchangeable potassium, and lime requirement if the soil pH is equal or less than 5.0, yung mga acidic soils. Now, let us look at the fertility status of agricultural soils in Benguet. This is a research or study conducted years back. Kaya, this might not be the current status of our soils today. So, we have here 10 municipalities out of the 13 municipalities of Benguet. So, we have Atok, Bugyas, Bukod, Kabayan, Kapangan, La Trinidad, Mangkayan, Tublay, Sablan, and Tuba. So, kung mapapansin ninyo, naka-range yung mga soil values natin. This is because madaming soil samples ang na-collect per municipality and iba-iba din yung nutrient status nila. Kaya, yung nilagay lang dito is the range of the soil samples or the range of the result from the soil samples collected. The third step is the interpretation of analytical result and the formulation of fertilizer recommendation. Okay, paano ba ito nagagawa? Okay, let's have a sample data from the result of the study mentioned earlier. Let's take two municipalities, Atok and Kapangan. So, a soil sample from Atok has a soil pH of 4.9, 3.35% organic matter content, 5.27 parts per million available phosphorus, and 1.07 parts per million exchangeable potassium. Dito naman sa Kapangan, iba yung result ng analysis. Now, let's say, for example, gusto ng dalawang farmers from Atok and Kapangan na magtanim ng cabbage. For example, sapat kaya itong content ng soil nila to provide the requirement of cabbage? Okay, to answer this, let us look at the nutrient requirement of cabbage. Okay, we have here the pH, the organic matter, available P, and exchangeable K. Ayan. Mas maraming numbers. Ano kayang ibig sabihin ng numbers na ito? Okay, we have here the crop, and then, according to this, the requirement of cabbage for pH is 6.0 to 7.5. And for organic matter, ito yung mga ranges niya. Alright? Okay, pag 0.2 yung level ng organic matter, that is very low. Kaya pag at ganito yung level ng OM sa soil, we need to apply this corresponding amount of nitrogen fertilizer. So in this case, pag 0.2%, we apply 150 kilograms of N per hectare. Pag greater than 4.5% naman yung OM, we only need to apply a lesser amount, which is 100 kilograms N of N per hectare. Okay. Now we go with phosphorus. Ito naman yung different level or ranges niya. Pag nasa 0 to 6 ppm, we need to apply 60 kilograms of phosphorus fertilizer per hectare. Pero pag greater than 20 ppm, it is already sufficient for cabbage, kaya hindi na kailangang mag-apply ng phosphorus fertilizer. For the third element, which is the exchangeable K, pag less than 35 ppm yung content ng soil, we need to apply 75 kilograms of potassium fertilizer per hectare. And then, if it is greater than 75 ppm naman, there is no need to apply potassium fertilizer since itong amount na ito can supply or can support the cabbage to attain its optimum growth. Okay, so I hope you got how this table is used. We go back to table 2, which is the fertility status of our sample soils. Okay. Imamatch na natin ngayon yung content of the soil to the nutrient requirement of the crop. And kung ilan yung kailangan nating i-apply. Okay, dito muna tayo sa atop. Since 3.35% ang organic matter niya, it is within this range, we need to apply 140 kilograms of N per hectare. For the available P, it is 5.27, mababa siya. So we need to apply 60 kilograms of phosphorus per hectare. For exchangeable K naman, mababa din siya, 1.07. So we need to apply 75 kilograms of potassium per hectare. How about the farmer from Kapangan? Ilan ang kailangan nang i-apply? Okay, mababa yung kanyang organic matter content, so we need to apply 150 kilograms of N fertilizer per hectare. For the available P, 3.51, mababa din. That's why the farmer needs to apply 60 kilograms of phosphorus fertilizer per hectare. And then, for the potassium, mataas naman siya. So, it is above 75 ppm, kaya hindi niya kailangang mag-apply ng potassium fertilizer. Okay, so I hope you got that one. Let us summarize now yung ating fertilizer recommendation. Let's start with the atok farmer. Okay, so yung pH niya is 4.9. It is lower than the range that is required by cabbage, which is 6.0 to 7.5. So he needs to increase yung pH ng soil niya, kaya mag-recommend tayo ng lime application. For the nutrients naman, he needs to apply 140, 60, 75 kilograms of nitrogen, phosphorus, and potassium per hectare. So take note, this is per hectare basis. For the Kapangan farmer naman, no lime application is recommended since yung pH naman ng soil is within the range sa requirement ng cabbage. And for the fertilizer recommendation, he only needs to apply 150-60 of kilograms of nitrogen and phosphorus. No need for potassium since nasabi natin kanina na sapat na yung potassium content ng kanyang soil. So, dito, makakatipid siya ng potassium fertilizer, si Kapangan farmer. Okay. Paano naman kung yung area ng farmer is half hectare lang? Ito naman is nasa 1 hectare basis. Ano ang gagawin niya? And paano kung urea and superphosphate ang available na fertilizer niya? Ilan ang i-apply niya doon sa half hectare na garden niya? Okay, so that will be answered sa later part ng module 3, which is under fertilizer computation. Okay, so I hope you got the formulation of fertilizer recommendation basing from the result of soil analysis. This soil analysis diagnostic technique is advantageous since the need of the soil or crop before planting is determined. So, malalaman mo yung nutrient status ng inyong soil before you are going to plant your crop. And it is also more accurate because it measures the amount of nutrients present in the soil. It gives us a numerical value which we can interpret and base our fertilizer recommendations. However, it also has disadvantages. It is time-consuming and laborious. So, from the soil collection, preparation, and analysis, it will take too much time. And it will also need expensive equipment and reagents kasi nga sa laboratory lang siya pwedeng i-conduct. We go to the next quantitative diagnostic technique, which is the plant tissue analysis. Okay. Kung sa soil chemical analysis, yung lupa yung ina-analyze natin, dito sa plant tissue analysis, we collect a plant part or a whole plant at a specific stage of growth to determine its nutrient content. Okay, so this technique provides a direct measure of the nutrient status of the plant that reflects the nutrient availability in the soil. It is based from the principle that as more nutrients applied or present in the medium, the concentration in the plant increases as the yield also increases at a given point. Okay, so in layman's term, kung mababa yung nutrient level dito sa soil, mababa din yung magiging result ng analysis dito sa above ground biomass. Pero kung mas mataas din na level of nutrients yung makukuha natin sa plant tissue analysis. There are precautions that we need to remember when we are going to conduct plant tissue analysis. The first one is that it is critical that the correct plant part be sampled. And every crop, iba-iba yung plant parts na recommended for plant tissue analysis. Let's say, for example, the crop is soybeans. Okay, at seedling stage, maliit pa lang siya, so all of the above ground portions will be collected and analyzed. And then, if it is mature, the youngest mature trifoliate leaves from the top of 20 to 25 plants prior to or during flowering is recommended for plant tissue analysis. Okay, kung crop naman natin ay sorghum, if it is mature, the second leaf from the top of 15 to 20 plants or at heading is the plant part na nire-recommend for plant tissue analysis. The second precaution is the stage of growth of the crop. Okay, because the concentrations of most nutrients decrease considerably as the plant matures. Okay, paano pag corn yung crop natin before tasseling or before yung bulaklak niya dito? Okay, if it is before tasseling, the first fully developed leaves from the top of 15 to 20 plants will be collected. And if the plant is less than 12 inches tall, collect all of the above ground portions. And kung yung corn naman is nasa tasseling to silking stage, the leaves below and opposite from the ear of 15 to 20 plants will be collected. Okay. Now we go to the third one, which is the fertilizer field trials or biological test. This is based from the principle that the growth and yield of plants, if all other factors are favorable, are dependent on the supply of nutrient elements in question. Okay. Dito, pwedeng field or pot experiment ang gagawin dito sa fertilizer trial. So under this technique, several treatments of fertilizer, including a control, will be compared to answer specific questions under field conditions. Let's say, for example, we would like to determine the rate of nitrogen for a specific soil and crop. Let's say, for example, yung crop natin ay rice. And we are going to apply it sa field. Okay, ito yung magiging possible na treatments natin. Treatment 0 is no fertilizer applied. Ito yung sinasabi nating control or unfertilized plot. And then yung treatment 1 to treatment 4, ito yung different rates of nitrogen that we are going to apply para malaman natin kung alin nga ba dito yung pinakamagandang rate of nitrogen na i-apply sa ating crop. Okay, so treatment 1, 25 kilograms, 50 kilograms for treatment 2, 75 kilograms for treatment 3, and 100 kilograms for treatment 4. Okay, so pataas yung ating rate, and there is a uniform increment of the amount of the rates. There are several conditions that we need to follow and determine if we are going to use this technique. First, ano yung crop na gusto natin itanim? Second is the soil type or the soil texture. The season, kailan ba tayo magtatanim? Is it during the wet season or the dry season? And our management techniques. Okay. Ano naman yung advantages ng technique na ito? Okay, so if we choose pot test, it allows the possible simultaneous setting up of experiment using soils from different locations. Okay, so kung pot test ang pipiliin mo, pwede kang kumuha ng soil from Ato, soil from Kapangan, soil from La Trinidad, and then dalhin mo dito sa La Trinidad yung tatlong soil na yon, and you are going to conduct it sabay-sabay, and then pwede mong ma-compare yung characteristics ng soil na yon. Okay, for field test naman, plants are subjected to natural factors, especially yung climate. And then, this field test provides sound and dependable answers to what kind of fertilizer to apply, how much fertilizer to apply, and when are we going to apply the fertilizer. However, it also has disadvantages. It is expensive and time-consuming. Time-consuming kasi magtatanim ka pa ng isang season from the seedling stage to the harvest stage of your crop para matest yung capability or nutrient status ng inyong soil. Okay? For pot test naman, if this is disadvantageous in a way that plants grown are artificially conditioned under which it is conducted. Parang yung example natin kanina, kung kumuha ka ng soil from Atok and Kapangan and tinanim mo or tinamnan mo dito sa La Trinidad, yung climate ng Atok and Kapangan ay iba naman dito sa La Trinidad. So that is one disadvantage of the pot test. Okay, we go to the qualitative diagnostic techniques. Meron yung tatlo. So let's start with the first one, which is nutrient deficiency symptom. Dito naman, it is used to evaluate nutrients that are lacking in the soil by observing the growing crop. So may nakatanim ka dyan, you are just going to observe the appearance of the crop if there are possible nutrient deficiency symptoms that are being manifested by your crop. This is best if complemented by plant analysis and or by soil analysis. These two methods are discussed earlier. Okay, ano nga ba yung reasons for the occurrence of nutrient deficiency symptoms? The first one is the insufficient amount and supply of soil nutrients. Kulang talaga yung elements sa ating soil. Okay. So, I believe that you have discussed in Module 1 kung ano yung mga nutrient deficiency symptoms. Iba-ibang nutrients, iba-iba din yung nutrient deficiency symptoms that they manifest to our crop. Let's say, for example, a healthy plant looks like this. It is green in color. But if it lacks nitrogen or kulang yung na-absorb niya na nitrogen dahil low ang nitrogen in the soil, the leaves will become yellow or it will manifest yellowing. Okay? The second reason is the unavailability of forms of the nutrients present. Nutrients are available in the soil or present in the soil in their inorganic form and organic form. And crops absorb nutrients in their inorganic forms. Kaya kung mataas ang nutrients or mataas ang level ng nutrients in your soil pero nasa organic form naman sila, hindi yun ma-absorb ng ating crops. Ang magiging result, it will still manifest nutrient deficiency symptoms. Okay? The third one, there is no proper balance among different nutrient levels. At ang mga nutrients, meron yung mga antagonistic characteristics or nagkokontrahan sa availability for crops. Let's say, for example, potassium, calcium, and magnesium. Okay, example, mataas yung amount ng potassium, calcium, magnesium sa soil ninyo. Yung potassium, however, kung very high yan sa soil, it limits the availability of calcium and magnesium for crops. So, parang pinipigilan niya yung pag-absorb ng crops para sa calcium and magnesium. Ang magiging result, magmamanifest yung crop natin ng deficiency symptom for calcium and magnesium. Dahil nga, hindi siya naka-absorb ng calcium and magnesium due to the restriction of potassium. Okay? This technique also has limitations. First and foremost, it requires expertise. This is because some nutrient deficiency symptoms are difficult to identify, and some nutrients have similar or almost similar nutrient deficiency symptoms. Let's say, for example, yung nitrogen and sulfur deficiency. Kung makikita natin, may yellowing siya. So, if you are not adept or you are not a very keen observer, if you lack experience in the observation of nutrient deficiency symptoms, you might be misdiagnosing your crop. Third limitation, plants may not show hunger signs not unless the deficiency becomes acute. So this is what we call the hidden hunger. To better understand what hidden hunger is, let us look at this figure. Okay, so dito sa y-axis, we have the increasing plant growth. Sa x-axis naman is the increasing concentration of nutrient in plant tissue. So very low hanggang very high concentration of nutrient plant tissue. Dito sa range na ito is what we call the sufficiency range. This is the range of tissue concentrations at which the supply of nutrient is sufficient for optimal growth. Below it is the critical range. Dito naman, the supply of nutrients is just marginal and the growth of the plant is expected to decline if the nutrient becomes any less available. Then we have what we call the hidden hunger below the critical range. In here, plant growth is likely to be reduced but no deficiency symptoms are visible. So, the lack of nutrients is not enough for symptoms to occur. And then, we have the deficiency symptoms. Deficiency symptoms will now show if there is a very low level of nutrients than what the plant needs. Okay? So, dito sa hidden hunger na sinasabi natin, kulang pala ng nutrients yung soil natin, pero hindi pa niya pinapakita na kulang pala. So, meron yung mga instances na hanggang dito lang yung effect ng nutrient levels. Ang magiging result niyan, the plant will not reach its optimum growth kasi may kulang pala na nutrients. Okay? The fourth limitation, abnormalities in plants may not always mean nutrient deficiencies. Abnormal plant growth may be because of the lack of water or caused by waterlogging. Okay? Baka naman nag-wilt yan, akala mo may kulang Akala mo bronzing ng leaves, yun pala is it's just a lack of water or yung kabaliktaran na saturated yung ating soil. The fifth one is the overlapping of symptoms. Now, it is possible na maraming nutrients ang lacking sa ating soil. And then, sabay-sabay sila na mag-manifest ng nutrient deficiency symptom, it can cause confusion in the diagnosis of the crop, in the diagnosis of the specific nutrients that are lacking in our soil. Okay? Then, the last one, sometimes, nutrient deficiency symptoms resembles those of disease infection, injuries by pest, or overdose of pesticide. Pwede din yung over-application of fertilizers. Say for example, nag-apply ka ng foliar fertilizer na very concentrated, in-spray mo sa crop, nasunog. You should be mindful of that because you might be misdiagnosing it as bronzing due to calcium deficiency. Okay, so let us be mindful when we do this type of diagnostic technique because there is a very high possibility or there is a possibility of misdiagnosis. Okay, for nutrient deficiency symptoms, there's an important aspect that we need to remember. First one is chlorosis. This chlorosis is the yellow discoloration of leaves and this damage is reversible or pwede siyang masolusyonan parang dito. Nag-yellow siya due to lack of nitrogen pero pag nag-supply ka ng nitrogen fertilizer, it can go back as a healthy plant, magiging green yung leaves niya. So this chlorosis is a characteristics of nitrogen, magnesium, sulfur, and iron. However, kung nasobrahan naman, due to a severe deficiency, plants turn necrotic. Ano naman itong necrotic or necrosis? This is now brown discoloration, parang ganyan. And the damage is irreversible or hindi na siya pwedeng mabalik kasi namatay na yung plant na yan or yung part of that plant. This is seen mostly in potassium deficiency, manganese, and copper deficiency. Okay, the second one for the qualitative diagnostic technique is the use of soil test kit or STK. This involves the use of specialized chemicals and dyes wherein the intensity of color developed is referred to a correlated color chart that interprets the relative condition of the soil. Okay, so parang ganito yung soil test kit natin dito sa laboratory. In using this, pwede mong ma-determine yung pH ng soil, its nitrogen content, the phosphorus content, the potassium content, and lime requirement. This is advantageous because it is less costly and a rapid procedure as compared to the soil chemical analysis. Okay? Ano naman yung pinagkaiba ng ating STK sa soil analysis? Okay, so sa soil analysis ay malalaman natin yung exact values ng NPK. Dito sa STK, it will only be described qualitatively. So for nitrogen, it is either low, medium, or high. Phosphorus is low, medium, or high then. And for potassium, it can either be sufficient or deficient. Okay, let's say for example, may soil tayo na ang N ay low, yung P is medium, and K is sufficient. And the crop to be planted is broccoli. Ilan yung i-apply natin na fertilizer based from these results? Okay, so we are going to refer to this table kung saan may mga crops na dito. There is the level of elements here, yung nitrogen, phosphorus, and potassium. And then, meron yung recommended amounts of fertilizer that is recommended to be applied. So, yung crop natin is broccoli. And yung nitrogen natin is low. Kaya, ang i-apply natin na ammonium sulfate is 7.6 to 20 grams per plant or per hill. And then, for phosphorus, it is medium. Kaya ang i-apply natin, 2.8 to 6.1 grams of superphosphate per hill. Okay, then for K, sufficient siya, kaya wala na tayong kailangang i-apply na muriate of potash. Kaya yung fertilizer recommendation natin for this specific soil and crop is 7.6 to 20 grams of amosol or ammonium sulfate per hill and 2.8.6.1 grams of superphosphate per hill. Okay, so that is how you use the STK as a basis for fertilizer recommendation. The last one now is microbiological method. This method is used to approximate the degree of deficiency or sufficiency of elements as indicated by the growth of the pest organism. Ito naman, gumagamit dito ng microorganisms. Okay, so two organisms are found to be efficient. For the approximation of the degree for phosphorus, potassium, and calcium, we use the azotobacter plaque method. And for K, magnesium, zinc, and copper, we can use the Aspergillus-Niger method. Okay? These ones, it needs to have, these organisms, dapat available yan. Kaya, this one, it is seldom used in our laboratory. The last part of our discussion for today is the other factors to be considered in formulating fertilizer recommendation. First is the season of the year. Is it conducted or is the planting conducted in the wet season or dry season? And then the economic value of the crops, the soil moisture conditions. This is related to the season of the year. Okay? And then the nutrient preference of particular type of crops. For grain crops, ang mga ito matatakaw sila ng nitrogen. And then for legumes, matakaw naman yan sa mga phosphorus. And yung mga sugar, fiber, tuber, and oil crops natin, matatakaw yan sa ating potassium fertilizers. And then, the last factor is soil pH. Ang ating mga crops, may mga kanya-kanyang requirement yan na levels of soil pH. May mga tolerance sa acidic soils, may nire-require na dapat nearly neutral. Meron din yung kayang mabuhay and maging productive at alkaline conditions. So, tignan natin yung mga crops and their pH requirements. So, this is based from the STK Green Book. Okay, for the strongly acid soils, ito yung mga common crops that can thrive. We have the tomato, coffee, Irish potato, cowpea, pineapple, upland rice, the sweet potato, radish, and so on. And then for our moderately acid to neutral soils, ito naman yung mga crops that require pH starting from 5.8 hanggang 7. We have peanuts, the ampalaya. We have muskmelon. Yan. Ito mga pepper, onion, watermelon, and so on. And then, for moderately alkaline soils, ito naman yung pwede nating itanim. You have the okra, rubber, avocado, corn, cucumber, sugarcane, mango, banana, cabbage, sorghum, and alfalfa. Determining the pH of our soil is important para malaman natin kung kailangan ba nating i-adjust yung pH ng soil natin para sa ating napupuso ang crop, or baka naman optimum na yung pH ng soil natin para sa gusto nating itanim na crop. Alright, so that's it for our discussion for today. Thank you very much and always keep safe.